Hello and welcome back to Mikey's Flightdeck. Today with the configuration of my fire panel. In this video I want to go into the configuration of the fire panel in Prosim and MobiFlight. This will be the first video that will be about the configuration only, because I want to have a better separation of the pure building process and the configuration of all my components in the future. So let's dive into the configuration now. Let's start in Prosim, where all the configuration takes place, and you go under Config and Configuration and the Combined Config tab. And here you will find everything that you need in the fire category, and we will use all the three underlying configuration categories here. First of all, we have the switches here. Here we have all the cargo fire configurations, but these are only needed for the cargo fire panel. You just search for everything here with fire, and down here you will find all the things you need: the fire handle switches and all the other switches on the panel. The indicators can be found here in the indicator category. Again, ignore everything with cargo and search for example the APU configurations and the other things here, engine, fire, and the other indicators. The last section needed is the gate category here, and there you will need the fire handle unlock configurations. These will be used to control the movement of the servo motor that opens and closes the locking mechanism. In MobiFlight I have added new devices to my Arduino L configuration. You can see this up here in the MobiFlight Modules tab. My Arduino L is the only Arduino Mega that is connected at the moment, and down here you can find all the configurations I have made. The 3 servo motors to control the locking mechanism, lots of LEDs and switches, and the first time now you can see here a shift register. I was running out of pins, especially when it came to control all the switches and LEDs. And I thought this can be a good point to start with a new shift register function in MobiFlight. And so I have added 2 shift registers to my Arduino Mega breakout board and connected all the LEDs to them. And so you can see this here with 3 pins of the Arduino. I can control now up to 16 LEDs. And I think there are 13 LEDs here to control, and all these are connected to the 2 shift registers. And this can save you a lot of pins on the Arduino. By the way, if you are asking yourself now, what is it all about here, these devices and MobiFlight modules, then watch my dedicated MobiFlight video where I go into every step in detail if you are new to all this configuration stuff. There shouldn't be too much new configuration work for you. Most of the work is configuring again LEDs and switches, and this is, when you have seen all my other videos before, a well-known topic for you. So here in the input configuration tab, I have again made all my configurations for the switches, all these 3-way switches, and the locking override push buttons, as well as the bell cutout push button and the 3 pull switches for the handles. In the output tab, I have configured all the LEDs and some special configurations for the unlocking and locking mechanism. And I will go into one of these configurations in detail in a moment. Let's try the test of all these basic components, switches and LEDs first, and then go into a special topic. I have running prepared in the background and already hit the run button here in MobiFlight, so I'm synchronized with the simulator and Prosim. Let's start the test of the LEDs first, and here with the engine 1 overheat you can see it lighting up there. Engine 2 overheat is working too. And the 2 bottle discharges, the left one, the right one is working. And these annunciators here, wheel well is working. There we have fault, APU and APU bottle discharge. They are working. To test these green LEDs down here, we can switch over to Prosim, and down here we can also initiate the test of the indicators. And the lower one here is the APU bottle indicator. We can just click onto the off here and the lower one is lighting up. And the other two we find here. The left bottle indicator is lighting up and the right bottle indicator, there it is. So these lights are working. The handle lights are still missing. So we have here engine 1 fire handle light is lighting up. The APU fire handle light, there it is. And engine 2 fire handle light here is lighting up. So all the lights are working. Let's test the switches. And let's start on the left side with the overheat detection. Let's move this to A. There it is. And B works. And the middle position, there we have it. And the test button down, in up. Also some lights are going on. Very good. And the overheat fire, there we are. And back again. So over here to the right overheat detection, and on B is working, middle and A, and there is something not working here. I have to check this later here if a configuration or a hardware fault is there. So when you have such errors here, check the switch first, if the switch general is working, and then move your way up. If the cable connected to the switch right, is it soldered in the plug on the right place, and is it soldered on the right pin on the Arduino, is the pin working, and so on. So I will have to move my way through this failure detection, but I think in this video this would be too much now here. So let's jump over this one test here and move on. Engines here, 1 is working and 2, there we have it, is working. The bell cutout button we can test as well. We have just to search it here in Prosim. And up here we see bell cutout, it is on off at the moment. And when I push this button, it changes to pushed and off again. So this button is working too. The tests of the 3 override buttons I will make now later when I explain you the configuration of the fire handles now. The fire handle configuration is not so much about the switch itself or its lights. The most complicated topic in there is the controlling of the locking mechanism. This is closed most of the times, the switch is locked, And so we can concentrate on the times when this locking mechanism should be opened. I have built this with a servo motor. In the real Boeing, the manual unlocking is a mechanical mechanism and bends away the locking mechanism in some way, but I found this more easier to use a servo motor for this all and control the servo motor with the unlocking switch. So let's concentrate on the moments when the mechanism should be opened. And I have found 3 moments when this should be. First one, there is a fire and Prosim gives out the signal to unlock this switch. This is a gate and we can ask for the state of this gate, and so this can control the opening of the mechanism. The second one, when you push the manual override button, then this servo motor should also open the mechanism and let the handle be free. And the third one is something that comes from the design, how I have built my panel. So when the locking mechanism closes, the switch is pushed in and the arm of the servo motor goes into a gap in the handle. When it is opened, the handle isn't blocked anymore. It can be pulled out. But when the servo motor would go back again now, it would collide with the handle because the gap in this handle is on a different position. It's higher now because the switch is pulled out. And so I have to make sure that the servo motor doesn't come back all the time the handle is pulled. So again, the 3 configurations. First one, the official unlock signal. Second one, the manual override button. And the third one, the handle is pulled. And now we have to make sure that we have configurations for this. Let's have a look first in my connection sheet where I document all my configurations. This you can find on my website to download. And in this case here, I want to demonstrate you the configuration of the engine 2 handle here. And there are the 3 configurations. L44, which is the manual override push button. Then here is the configuration L43, which is the control of the servo motor itself, and the configuration L42, which is the configuration if the handle is pulled. These 3 configurations give us all the information that we need, and we will combine the information of this configuration in a new configuration that I will make, and this will be configuration L72. This will be fire handle 2 servo control. This is not an official Prosim configuration or something like this. This is just a MobiFlight configuration that I will declare where I gather and work with all these configuration informations. First, let's have a look into 2 of the input configurations. There is L44, which is the manual override push button. This isn't causing a direct reaction here. The configuration is just listening to the device L44, which is my push button for the engine 2 handle, and then it saves the state of this push button in a variable, which I also called L44, so that I always know what I'm talking about. And when the push button is pressed, then a 1 is stored in this variable, and on release a 0 is stored. So I have always a variable that can give me information about the state of my override push button. And then here we have L42, which is the configuration for the handle. And this is a value where Prosim, or the simulator, is also interested in. So when the handle is pulled, then I have declared an offset, and on press, which means I have pulled the handle, then 1 is submitted, and on release, a 0. This is a normal button or switch configuration. And the value is transmitted via FSUIPC to Prosim, and it can work with this information. Let's move now here over to the output configuration tab. And let's start with the new configuration. I call this the master configuration that finally controls the state of the servo motor. I said this will be L72. And with this configuration, I will control the servo motor. L43 is the device that describes my servo motor, and I don't need the maximum 100% rotation here. I think 50% should be enough to move the arm into the gap of the handle and lock it. Let's make a small test now. Here you can see the arm of the servo motor for the engine 2 handle, and when I now test it, it slides into the gap. I think it is even a little bit too far. So over again, and let's try 45%. Yeah, this looks straight down here to the handle. So now we know how far the handle should be moved, and this is the main job of this configuration. So now this configuration has to look to all the information that it needs. Is the handle pulled? Is the main signal coming in, or is the override button pushed? And these things can be referenced down here, but we can only reference things that are in the same tab, so in the output tab. If you remember, at least 2 of the configurations are in the inputs tab, so we have to bring the informations now here to the output configuration tab. The first one is the information of the handle if it is pulled. So let's make a configuration L42, the same name like the configuration on the inputs tab. This configuration will look after the offset that I have declared. It is 5334, and I'm looking to the 1 bit. It shouldn't make anything more. There is no module declared, so it does nothing. Let's test this configuration now here. You can see now the fire panel here, and have a look to the value, the output value here in MobiFlight on the right for the L42 configuration when I pull this handle. So I'm now pulling the handle, and you can see the output value is a 2. And when I bring the handle in again, there we have a 0. So why is this working like this? Because we have declared the 1 bit, or better known as the 2nd bit of the offset. And so the value is 2. If we would have declared the 1st bit or the 0 bit, the value would be 1. And in our case, we just want to have a yes or no, or a 0, 1 answer here. And so we will make a transformation of this value here, and we go to the compare tab of this configuration. And I apply a comparison. If the current value is bigger than 0, then set it to 1. So it doesn't matter if it is a 1, 2, 8, 16, what can come there. it is always then a 1. Otherwise, set it to 0. So let's make the test again. I now pull the switch again. And you can see on the right here the flight sim value is a 2, but it is transformed into a 1 that says the handle is pulled. And now handle in again, and we have a 0. Now let's go to the manual override push button. We know we have it on the input tab, and now we need it in the output configurations tab. You remember we have stored the state of the button in a variable, and now we will use this variable. We will declare a new configuration L44, the name like the configuration on the inputs tab for this button, and we will now look to the MobiFlight variable L44. This is the name I have declared for this button, and we do nothing again here. So let's test this configuration. So I will push the button now, and you will look here on the right in the blue line which values will come. I'm pushing the button, and you can see we have a 1, and when I release it, 0. So there we have our second information. And the last, third missing information is the main signal from Prosim to unlock the handle. And this will be done in a normal output configuration. And I will call this L43, like I have written down before it in my connection sheet. And in this configuration, I will again look to an FSU IPC offset that I have declared in Prosim before. This will be 5334, and I will look to bit number 2. Again, I will do a comparison because bit number 2 will bring us a different number than 0 or 1. And so again, if the value is bigger than 0, then set it to 1, otherwise set it to 0. So I make sure that I only have 0 or 1 if the unlocking mechanism should be opened. And again, on the display tab, do nothing. So now we have all our 3 informations that we need here all together in our output configurations tab. One thing I have forgotten to do, and this is something what I always do when I have configurations that are not real configurations, but are used exactly in those situations that we need them here just for looking to them. And you can see this down here. I have done this for the other 2 switches. I'm adding the short word var behind it. And this shows me that this is not a configuration that is controlling something, giving an output or something like this, but it is just there so that another configuration can look to this. And this I'm making here just to make sure that I'm not deleting it for a mistake. So L42 and L44 will get the word var. By the way, when I'm thinking about this, L43 is again a configuration that is not really controlling something here, so it should get the word var too, like these other configurations here. Now let's go to our master configuration L72, which will make something with all these informations. And we will reference these configurations down here. The first one, L42. We will use it. We add the next reference, L44. And the third one, L43. These are represented now here by these signs. We will now make a transformation because the value of this master configuration must be 0. So the handle is moved out of the way. The servo motor goes back to its 0 position. If any one of these three configurations has the value of 1, so the handle is pulled, the button is pushed, something like this, then the servo arm must be out of the way. And this we can do with a simple formula. If the question mark or the exclamation mark or the hashtag. This is a short version of if the question mark is 1 or if the exclamation mark is 1. So this is just a short writing. So question, exclamation mark or hashtag are 1, then our value is 0, otherwise it is 1. So the servo motor moves in the locking position. And now go over to the display tab. And here finally we will make our output of the servo motor L43. This is right. And we have done this before. It makes a rotation of 45 degrees. So let's test this now. Oh, by the way, one thing I have forgotten. Select up here the FSU IPC offset, because otherwise when you have the SIM connect selected, then it would give you an error if there is no SIM connect connection. So just click on FSU IPC offset, let's everything here unchanged, and only the transformation and the references. These are the things that are important. So now I'm clicking run here in MobiFlight, but you can see the servo arm hasn't moved. The value is 1, so it should have been moved. Let's see again to the configuration on the display tab. Yes, and there is a problem. The value for this arm is from 0 to 255, but we don't have those high values now anymore. So the maximum value that we will receive is 1. And now you can see the servo has moved because it is getting the value of 1, which is the maximum value for it, and it moved in the maximum position, which is 45 degrees. So the normal situation in the cockpit, the handle is blocked and I can't pull it out. So don't try this too much. It's only a plastic handle and not a metal one. When you feel that the handle is locked, then you should believe it is locked. Let's try the override button first here. I will push it and the servo arm goes away. And when I now pull the handle, you can see the gap has slided away. And when I now release the button, the handle isn't going back to its position because the signal that the handle is pulled is there. So when I now bring the handle back into its position, you can see the servo motor is going back. Now let's simulate the normal situation. I will now initiate and fire in the engine 2. So there the light is going on and you have seen the servo motor has moved out of the way. And now I can pull this handle here and move it to the right. And let's control this movement to the right if this is recognized correctly. And up here you can see fire handle engine 2. It is on off at the moment. When I turn it to the right, you can see right is lighting up and the handle position in the displays tab is also correct. The bottle discharge is illuminated. And now the fire should be off. Yes, it is off. We will bring the handle back to its normal position. There it is off. The servo motor is still opened and we can push it in and the servo motor blocks it again. So here we have now made a very complex configuration work in Prosim, but everything worked like it should be. I don't know if it is working 100% exactly like in the real one. I don't know if you push it back after you have discharged the bottle, but for my setup and to save my hardware here, it works everything like it should be. So I hope you have learned something new from this video. You can download the connection sheet from my website. And if you want to build your own panel like this, you can download all the needed files from the member section of my website. So I hope we'll see you soon back on the flight deck.